All right. Any questions?
Not really.
So then let me just forge ahead with that mini project again. So it seemed to work okay with the recording last time, so we're trying this one more time. So I looked over what you guys did, and there were some problems with the mouse dragging and with the cloning, so I thought I'll spend a few more minutes with that. So let's look at the mouse dragging first. So when what we want to achieve is that when the mouse is dragged, that we translate the shape and then we update it. So first of all, that means we have to be able to translate those shapes. So it's going to shape. So we add a translate method. Then we do that for the various shape types. Now for the rect shape here, we have a rectangle, and so we just need to translate that. That thing has a translate method. And we can just call it. For the text shape, it stores the points x and y here, and so I need to just shift those. So x gets incremented by dx, and y gets incremented by dy. Those might be negative values, of course. All right, so now that's that. I don't have a graphics in my mock-up here, but in the graphics, you presumably also stored the x and the y, and then it's the same thing. All right, so now in the component, we need to worry about the events. So so the scheduling is a little bit complicated, right? So when the mouse goes down, then I don't yet know whether. Well, first of all, when the mouse goes down, I have to select the current element. So let's do that first. So we need to install a mouse handler. And we can do that anyway. I'll put it in the constructor. You know what? I'll put it. I could put it in the constructor. So the question where you put it is so I can put it into basically two places. I can put it into the constructor, or I can put it into the frame that adds the component. And the question you want to ask yourself is the methods for the mouse handler. Which values are they more likely to access? The values that you have in the frame class or the ones that you have in the component class? In our case, I guess I want to be able to mess with this private field here. I want to be able to set the selected one when the mouse goes down. So I'm doing the right thing. I'm actually better off putting it here. So it's add mouse listener, new mouse listener. I'll do a new mouse adapter so that I don't have to do all of the various methods. Okay, what's no. No, come on. I'll just import it by hand. So it's Java AWT event I know, just take all of them. So now there is. So I'm going to do mouse pressed. And it gets a mouse event. And there is a method called getPoint, I hope. Yes, getPoint. That gets me the point where the mouse goes down. So now what I want to know is which of them did I get? Which of them did I select? So the mouse goes down somewhere, and so that means whatever the mouse is in gets selected. Well, I have a list of shapes, so I'm going to go through the list of shapes, and the first one where the bounds contain it, I'm going to say that's the one. So so if gets bounds, get bounds has a nifty contains method. If it contains the point, then I'm going to say fine, S is the one, so selected is S, and I'm going to return so that I bail out of the loop. And if I go through the loop and none of them matched, then I'm going to say selected is null, and I'm also going to return. Now, actually, what I do need to do is now I'm changing the model. I'm changing, the model is all the shapes plus the selected one. So whenever I change the model, I have to repaint. Now here I've bailed out with a return because I didn't want to manage that loop, so I also have to repaint here. Otherwise, the selection change won't show. All right, so let's try that out. So, and that now works. You can see that these little grabbers. Oh, I had bad grabbers. Remember those pink grabbers up here? But they do pop up on the one that's currently selected. I'm not sure it works with the string because I think last time I didn't completely do the string. But it's good enough right now with the rectangles. All right. So that doesn't yet move them. So for moving them, I have to add a mouse motion listener. So that's now a new mouse motion adapter. And the method I need to override is, I believe, mouse dragged. And now this all is conceptually a little bit confusing, so let me just show you what happens if I just print out the current mouse point, where P is so now you can see down here these points here that are continuously reported. So now if you look at two of them, like the last two here, you can see that x was 156 and y is 130, and then x was 156 and y was 129. So when I see these two successive ones, then I should move the selected thing by nothing in the x-coordinate and by -1 in the y-coordinate. So that means I need to know the previous coordinate. So that means I need to have an extra instance variable here to remember that. I'll call it last mouse point. When the mouse goes down, I'll set it. That's here. Then here in the dragged, now I need to find out what is the difference by how much should I move. So dx is, I guess, p dot x get x minus last mouse point get x, and int dy is the same for the y. So I need to take the selected shape and translate it by dx and dy. Okay, now why do I get wiggly underlines here? That's annoying because getX returns a double and not an int, even though they're all going to be integers, right? They're mouse points, they're pixels. I think I can actually say p.x. Let me try that. I think there's a public field x. Or I could cast. Yeah, this works. So weirdly enough, some of these classes are ancient, and so they give us the actual field access, and whatever works. You could cast, and that would work equally well. So let's try that. So I'm going to click here, and nothing happens. Why not? What's that? No repaint. Yes, no repaint. So let's see what happens now. And now I took out the printing. Ooh. What happened? I don't actually know what happened.
So that happens so when I'm thinking while we're dragging it keeps translating too fast.
Right. So what can we do to fix it though?
In my code I try to divide, I try to make the dx and dy small.
But one has to have an accurate way of doing it. If you just kind of wing it, it's not going to work.
Can you just set its absolute position rather than having the
Yes,
stuff?
yes, and that is the better way of doing it. And so, so if I have the original bounds here, then, and now the mouse pointer. So what I can do is I can remember its original position. And now I can make it so that I make sure that if the mouse now is here, that becomes its original position. So let me force it so that that I'll now make the mouse. So I'll make I'll make the top left corner of the shape to fall at P. Now that's a little bit awkward with translate, but translate is all I've got. So I need to get the current bounds. And so now I get the top left corner, and let's try that. And now you see it drags nicely. But there's just one odd thing about it. So pay careful attention to what happens right now. I'm about to click. What happened? What happened the first time? So afterwards it's all fine, but the first time I'm clicking in the middle, and now what happens? Yeah, it moves to the top left corner, right? And so that's the problem with this approach. It's nice and smooth, but one needs to correct for that. And so the way to do that is as follows, that when the mouse goes down somewhere in the middle, that you remember this offset. And then from then on, you always adjust by that offset. Then that way the mouse will stay in the correct position relative to the top. So that means instead of storing the last mouse point, I can store the mouse point when the mouse went down. Let's see. No, I'm going to store the offset. Offset X, offset Y. I'm going to compute them in here. So when I have when I found a selection, what did I say? Now I need to get the bounds. That's a little wasteful. I put it up here because that way I don't have to call it twice. So then the offset X is R dot X minus P dot X minus P dot Y. And then over here, I now need to adjust by the offset. Now is it plus the offset or minus the offset? I'll do it both ways and find out. I guessed it right. So now it's all perfectly nice. So now it remembers where the mouse was in relationship to the thing, and it drags it fine. Okay, now there's a minor thing. What happens if I click here? Then I get bad error messages in here. And so there was a null pointer exception somewhere. That's when I clicked in the middle or nowhere and nothing was selected. So in the mouse motion listener, if there's nothing selected, I should just bail. Alright, so that's how you get smooth mouse motion. And it's a little odd that you can't just look at the individual mouse motion events, but apparently there's an error that accumulates. And just trying to somehow divide by some factor or something is not going to work robustly. So one has to just say, okay, since apparently looking at the differences doesn't work, one has to say, what do we actually know? We know the mouse position. And then you just work with that. Next, the cloning part. So we already have the copy button here from last time. And now we just need to make it do the cloning. So let's see, where do I have my buttons? Those I now have in the frame. All right, so just like in the previous case with the deletion, there's nothing much I can do at the level of the frame about deleting or copying. I have to defer to some method in the component. The component owns the component state. So I'm just going to call a method comp clone selected. And here was delete selected, so clone selected presumably is pretty similar. So this time I'll put the call to repaint first so I don't forget it. So I need to get the selected one and just clone it. That's a shape. I add I need to translate it by a little bit. Clone to translate. 1010 sounds good. And then I add it to the shapes. And that's all that's required, except now for some technical details with the cloning. So let's see. So we get a wiggly underline here that says clone is undefined for the type shape. Oh, okay. That's actually a little bit weird because clone is inherited from object, so everything does have a clone, but weirdly enough we have to declare. So let's add it in. Oops, I thought I had to find it. I didn't save. Okay, so now everything looks like it compiles, so let's run it. All right. I get a clone not supported exception. And here it says the inherited method object.clone cannot do what? Oh, and the other thing is that the return type is not compatible. So in shape, it says I'm going to be returning a shape and not an object. So it looks like I actually do have to write some amount of code to get this to work. I could put this in object and then cast it, but it seems nice to do the right thing. So, and this is something we haven't really done much with cloning, so you have to maybe refresh your memory on that one by reading that section. So let's implement clone. So I have to call super.clone. I have to cast it to the correct, I can cast it to shape. In fact, I could be nice and say this one is a clone of a rectangle is of course a rectangle, so let me declare this as a rectangle and then cast as a rect. It was a rect shape, All right, and now I have to worry about what to do with the pesky throws clone not supported exception. I have two choices. I can throw it and then catch it later, or I can catch it here because it's not going to happen. I know exactly what a rect shape is. A rect shape has a color and a rectangle and a boolean. None of those, when cloned, throw a clone not supported exception. So I could at this point say, well, that's just not going to happen. And so, in case that the impossible does happen, I'll print a stack trace. So this will work, and you can have philosophical arguments about whether this is the best you can do. I could maybe turn it into an error and throw the error. That might be a good way of dealing with it. I've also seen people, instead of putting a print stack trace here, I've seen people just put assert false here, and that way you can run it with assertions. Either way, so we say this is an impossible case. Otherwise, we'll just return the clone. All right, so now we've done this for the rect shape. We also have to do it for the text shape. In this case, it returns a text shape like that. I could have actually made this a default method, and then I could have put it into the superclass, then here with a shape instead. That might have also been a good idea. So let's just have a double check here. Can one clone this thing safely? I'm not actually sure if you can clone a font. So let's double check that. That's not so happy here. You see that a font is not clonable. So that means I have to not clone the font. And so in this case here, then I guess, did anyone run into this?
I did it a different way somehow.
Okay. What did you do?
I just had each shape. It has its own constructor which accepts an argument of itself, so you can just put all
Okay. Okay. Yes. So in this case, there's various ways of defeating this, and the easiest way is, in fact, to just construct a new object and bypass the cloning mechanism. And so it's a hassle with cloning because you ever so often run into classes that don't do the work of being clonable because, as you see, it's a hassle. So, but that will perfectly work. So let's return a new font, a new text shape. Let's see, what does a text shape need? It has an XY, the font name and the font size. Excuse me. And now the text string and X and Y. And then here we go. So now when we say copy, now let's see what happens. Oh, I got a null pointer exception. Why is that? Yeah, look at this. So selected.clone, the thing that I thought couldn't happen must have happened. That it returned a null. Why is that? Oh, I know why. Shape, I need to extend clonable. I need to make sure that every shape is clonable. So here we go. And here's our clone. What happened to the original?
I think maybe rectangle is clonable.
Rectangle is clonable.
Because in my case it doesn't work. I have to use the rectangle to read.
Well, here's the thing. Rectangle is clonable, and so it did make a clone of the. Well, here's what. Let's see what it made the clone of.
So it's just a pointer to the.
Yes. So we didn't do a deep copy in the clone. So if we go to the rect shape here, we call super.clone, and that's not good enough. What that does is it makes a copy of this object, and it makes a shallow copy of the object, because object.clone only makes a shallow copy. So when you go to the book, there was this tedious thing where it says, well, we're now using this example with a date instead of the local date because that thing is mutable, and then one has to make sure to make a copy of all of the mutable sub-objects. And that's exactly what you're running into here right now. So we made a copy of the rect shape, and that now is a new object with new fields, but both of the rect fields point to the same rectangle. Then when we call translate on the shape, that calls translate on the rectangle. That's the shared rectangle that gets translated. So the remedy here is to go in here and to, before returning this thing, to also clone the rectangle. So let's do that. So then this is the rect shape result. And now I have to say rect shape, no, result, sorry. Result dot what did I call this thing? Oh, yeah. Is r.clone. Okay, now I have to do all of this tedious thing again. I have to cast here. This is a rectangle. And I'm already catching the clone not supported exception, so I'm good. Okay, now what's it? Oh, I didn't return anything. And return result. And now here's our copy. Now actually, when you do this, it's nicer to select the copy as well, because probably the user wants to move do something with the copy or move it away, and now the wrong one is selected. So that's a cheap thrill. Where was it? It's in the frame. Oh yeah, it wasn't here. So just make the clone one the new selected one. That's it. All right, so that got us to the end of the last stage. So let's move on here to the next one here. So we want to be able to add more shapes here. I'm going to skip the first. Well, can I skip this one here? No, I can't skip it. So I'll have to put. So we need to make a text field and an add button somewhere. So that'll be again in the frame class. See, I already have a bunch of buttons, so I'll call the text field text field. Oh, it's a text field. So when an add button gets selected, then I need to put them put them into the panel somewhere. Hopefully there's enough room. I'll just put them all next to each other. So we'll add a new action listener here. And it needs to read the string from the text field. And now we need to do the same kind of stuff that was going on in here. So it would be a good idea if we could somehow factor out this thing here into a separate method and then just call that here. I see, so somehow I must have caught that. So it asked me here for an input parameter of scanner, and that's not what I want. I want it just to have it just a line. So let me grab it from here. Refactor extract method. Yeah, so now I'm getting a string parameter. So now it extracted this here into a private helper method that I can call. Just call this one line for consistency. And then say add from line. Okay, let's try it. Let's see if I can get a line somewhere. Okay, why doesn't anything happen? Well, because I forgot to call repaint. Okay, so let's do that in here as well. Okay, now what do I repaint? I can call repaint on the frame, or I could call it on the component, which is slightly more elegant. Oops. All right, so that's that, and that's only a minor part. But you did see how I used to good effect this feature that you can extract a method. You just highlight all of the lines from the method, like I had done here, and then use, say, refactor extract method. Where is it? Now it's blanked out because I can't do anything. And then Eclipse is smart enough to figure out what are the things that need to flow into the code that you highlighted as parameters, and then it offers you the parameters. And when I did it at first, I did it wrong. I also highlighted this line here as part of the thing to extract, and then I said, oh, I want to feed in the scanner in, which is not what I wanted. I wanted to have a line, and then I knew that I had to make an adjustment. So extract method is definitely a nifty way in Eclipse on how you can restructure your code if you need to, if it gets too complex, or in this case, where I wanted to call a bunch of lines from two different places. All right. So that was not the hard part. Now we're coming to this tedious part where it says that we want to do this general shape class that has an instance variable of type java awt.shape. Okay, let's go for it. We've added other shapes, so how hard can it be? Alright, so we need to implement a bunch of methods. Yeah. So there's a thing called add unimplemented methods, and then it adds them all. So let's see, what did the general shape have? They told me what I was supposed to put in. It has an instance variable of type java awt.shape, whatever. So I have to use java.awt.shape because I have a shape in the default package, and the two are different types with the same name. And I'll call it shape. Now to draw this shape, I guess I just need to pass it to G2 and say G2.draw. Or can I fill it, or is it always drawn? Does it say? Well, it says call draw or fill, so I guess I need to have a fill state too, just like before. Alright, now to get the bounds, I believe the shape has a method called getBounds. It does indeed, so I just defer to that. We'll come to translate in a minute. To clone, well, I guess I need to clone the shape. And this is again a little intricate, as cloning always is. We don't really know that generally shapes are clonable, but all the ones that I'm going to be trying, I've checked it out before making the assignment. They are clonable. So we're going to boldly go and clone the thing and hope that it'll work. Now when it does, Now when it doesn't work, I'm going to throw a runtime exception because that would actually be bad. Oh, I see. I can't even do this. This is always tedious. Now I ended its cause with X, and then I throw the runtime exception. And the reason for that is that clone not supported exception is a checked exception, and I don't want the hassle of dealing with checked exceptions every time. All right, that's clone. Now translate is annoying because the the shape interface does not have a translate method. It easily could, but for some reason they didn't put it in. And so now what does it say here? It says you need to work a little harder, make it so that general shape has an x and y coordinate that's updated in translate. That part is easy enough. Oh, private. And now, in the graphics context here, we're going to adjust the graphics context by x and y. There's a way of shifting it. And I'm going to do the drawing and then shift it back in the other direction. And that has the effect of moving the shape to whatever x and y are right now. So does it tell us here how to do this? Yes, it says call translate. So here it is. So we'll translate it by x and y. And then later we change it back the other direction. I can never remember which way to do the translation. I think this one is the right one, but we'll find out soon enough if I did it wrong. So you can what's called change the viewport coordinates. And that's actually a very powerful thing. You can scale and share them as well and get all sorts of interesting effects that way. But the translate part has been a lifesaver whenever you need to do this kind of stuff. All right, so that means that in get bounds, this is now not quite true because this might have been a translated shape, and I need to return the translated shape here, not just the bounds. So let's fix that up. So I have a rectangle result. And now I would like to call, okay, no, I return result. I would like to call result.translate by x and y. But of course, for doing this, I have to first clone this guy, because if I were not to clone it, then I would mess with the original. So that's fine. There may be another way of doing it. I believe there's actually a constructor for rectangle that takes another rectangle. We could look that up. Yeah, here there's a rectangle of rectangle. That maybe is a little faster than cloning it. So and then I can safely translate that. Now translate itself, all it does is it updates the x and y like what we have already had before. So that's the plumbing for it. The hard part is this reflective stuff that comes next. So now it says, finally one needs to construct these shapes. So we're getting in the constructor the name of the class and its construction parameters. So let's assume we're going to get all of this here as one string. So over here, what are these? These are the color values and the original x and y position. So let's just set those real quick. Oh, and I forgot all about the color. You can deal with the color. So let's see, I can't remember this. So we had RGB, fill, X and Y. And then that string, I'll just call it line again. This color is new color. This fill. Alright, now we're going to have to distill this thing into a shape. That sounds like a complicated thing. I'll just put that into a new method. So let's see. So we have a weird looking line like this. And then we have these construction parameters that are here. First of all, it seems sensible. Let's see. Are we actually having them as a line? Let's see in which context we're getting them. Because I don't really want to mess with the code that deals with this stuff. This was already done with split. And so we're in this add from line thing here. So we're already calling split. So let me actually just start coding this here, because I need to do it eventually anyway. Fields of 0 equals general shape. Now I add a new general shape. And now its construction parameter takes pretty much the same thing as what we've had before. This is RGB, here's an XY. So I can copy all of this. And now I have these other things. I already have them pre-split in an array, and I guess I could shovel them into another array. There's unfortunately no good way of taking something out of an array. Now that's actually a good question. So let me just draw you what my technical challenge is that I want to overcome. So I have an array where like the first 6 elements I don't want. 6 or 7, I can't remember. Let's say 6. So I don't want these, but then there's a bunch of other elements, and I want to pass this stuff here in some way to this method, the remaining 5 or 6 elements. And yeah, I could make a new array and move these all over, but there's got to be some better way. I can't erase these because I can't erase anything from an array. Now I could erase from an array list. So if I turn this whole thing into an array list, then I can say, I don't want these anymore. And the easy way to turn it into an array list is, of course, to call arrays as list. So I could call arrays as list and get the whole thing. And then I want to have then I want to get rid of these first ones here. And the way to do that is to make one of these views, to say, just give me a view of the rest. And So we'll have arrays as list of fields. And now, oh, I don't have arrays. And I believe the method was called sublist. I have to look it up because I can't remember. Or was it in collections? It wasn't. It was in collections, right? Yes, one of you have the book. Look in the section on views on how the heck you make a view of, because I can't remember. So it's in chapter 8, and it's called views, I guess. And for the life of me right now, I can't figure it out. And I don't have the book on this computer. That's if one of you could spring to action here. Let's see if I can find it faster. Okay, here it is. It is called sublist. And so then we would want to have the sublist from 7. Okay, why does it? It is not available for the integers int. Okay, whatever. Fields length. And now we're going to change the general shape to not get a string of line, but a list of string. Fields. Okay. Now get list imported. And then this should also get a list of string. Alright, so come on. Oh, fields. So now we're going to here you get an interesting error. It says type mismatch cannot convert from shape to java.awt.shape. That's an easy thing to get wrong in this. So this one here returns a Java AWT shape. That's what I want to make. So now we're having a name of a class, so we need to get the actual class for this. That's class for name. And the string that gives us that is the initial one, fields of get of 0. Now we are going to get a bunch of exceptions, and if you recall from that chapter, they're all reflective invocation exceptions, and so I'm going to catch them and return null in that case. Pretty sure that's the right name. Oh, reflective operation exception. Okay. There we go. All right. So, if now we need to call a constructor on this class, and so the tedious part is we don't really know which constructor. If we look at a particular shape, let's look at, for example, at round rectangle. There's a thing called round rectangle 2D dot double. Here it is. Then you can see this thing has two constructors, one with no arguments and one with a bunch of doubles. And that's the one that we want. So let's see what the setup, what the instruction set is. Look through all constructors and find one that has the right number of arguments, all of which should be int or double dot class. So I guess that's what we have to do. We have to look through all of the constructors. There is a method that gets us all constructors called getConstructors, I would imagine. Here it is. So that gets us a constructor object. An array of constructors. And now I have a constructor. I need to find out, is it good? So I'm supposed to find out two things about it. A, is it does it have the right number of arguments? So this fields list here is it's the class itself, and then the construction arguments. So the remaining ones as the right number. So I'm looking for a constructor with fields.size -1 parameters. So let's see what I can tell about it. There's a get parameter types. That's not bad. Maybe there's a get parameter types. That's exactly what I need. So let's call that. And so that's an array of class. Params. And so let's find out how long it is. So if params.length equals fields.size minus 1, then it's a good candidate. And now I need to look at all of the parameters that are in there and see if they're all int or double. I guess I could make a loop, but I don't really want to do that. So I'm going to put them all in a set. Unfortunately, I can't put an array into a set, but I can put a list in a set. And now I have a set of all the parameters, so that way I don't have duplicates anymore. And if that set is either the set containing int dot class or double dot class or both, then I'm happy. If it's anything else, then I can't use this constructor. So so first of all, I want to make sure it's not the empty set, because that would mean that the constructor has no parameters. Oh, I see. Fortunately, I can't quite do it like this. Now I'm going to take the set and remove int dot class. And remove double dot class. And if now the size has become 0, then I have found a constructor that I can call. So in that case here, I can remember it.
Question.
Yeah.
So the parameter types can be both integer and double. So I mean, the parameter types can be mixed.
Yes, there's some way that happens. Yeah, otherwise it would be a little easier, but so I have to do it one parameter at a time. So now I'm going to remember here C, and then I'm going to invoke C. So now I'm going to now I want to invoke the so if it's null, I'm going to return null for now. And so now I want to invoke the constructor with the right parameters. There's got to be some way of doing that. So constructor, let's call it new instance. Okay. And new instance takes an array of args. Here it takes it as a var args thing. Well, I have to make the array, so in that case it doesn't much matter. So it's an array of objects. I know how many I have. It's the number of fields minus 1. And Now I have to go through one parameter at a time and figure out whether to make an integer or a double, or because these are the only ones I care about. So oh, I didn't save the param, so that's unfortunate. Well, let's get him one more time. So if the ith parameter, arg_stud length. If the ith parameter is is int.class, well, I have no idea. Then I need to somehow make a new integer of fields. Oh, I see. Now I need to do. Now I have to find out how to turn a string into an integer. That's integer.parseInt, right? So then args_I is integer.parseInt of something. I'll leave that for you to figure out. And so on. So at this point here, you're going to be calling new instance, and that's not going to be constructing that. It's not going to give you the shape, and you can return it. I guess one has to cast it to Java AWT.shape, which we know it must be, and they don't. All right, so that's, I guess now my time is really up. So that's all I can tell you for hints. So get all these details worked out, and it'll work fine. The final one is not really hard. That's just a matter of cosmetics. I've given you the solutions that people had for up to part 2. Like I said before, feel free to study and profit from them as you like. And so hopefully this video will have come out, in which case I'll put it on YouTube and you can use that as well.